As we started to see in the previous lesson, the railway sector can be seen as an intricate energy system made of a large number of trains, rolling stocks, and stations with different sizes and characteristics. Given the complexity of the current situation of the Italian railway system and related infrastructure, it is relevant to define a shared taxonomy to describe the sector, highlighting today's characteristics and future alternatives. It is meant to A. Systematically organize the railway components, stations, rolling stocks, tracks, and defining the sector clearly, highlighting attributes. B. Ensure uniformity in characterizing the infrastructure and establishing sharing terminology and standards. C. Support planning with a holistic network perspective and facilitating future scenario prediction and planning. For example, renewable integration, hydrogen technologies. The proposed taxonomy distinguishes between electrified and not electrified component, identifies 3 levels of energy consumption, which are station, vehicles, and tracks. For stations, the taxonomy elaborates on the various services they provide, including signaling, control, and auxiliary function. In the case of vehicles, the table sheds light on the diversity of onboard services, propulsion systems, electric or not, and vehicle typology, revealing the range of trains that traverse both electrified and non-electrified tracks. Regarding tracks, the classification is attentive to their electrification condition and configuration, particularly distinguishing between double and single rail setups. Italy has an extensive network of railway stations, ranging from small local stops to large urban terminals. These stations serve as a critical hub for passenger transit, facilitating seamless connection between different regions. RFI, the largest operator in the framework of railway infrastructure, operates approximately 2,200 stations throughout the national rail infrastructure that are classified into platinum, gold, silver, and bronze categories according to the RFI service charter, based on their available services, passenger volumes, and energy consumption patterns. Platinum stations serve over 25,000 daily passengers. These facilities provide top-tier services for long, medium, and short-distance travel. Gold stations are medium to large stations with over 10,000 daily passengers, offering high-quality services for all types of travel distances. Silver categories covers medium to small stations with around 4,000 daily passengers, typically for regional and metropolitan services. These stations often operate without staff and lack major infrastructure. Bronze stations serve fewer than 500 passengers a day. They are usually unstaffed and limited to regional or local services. As can be seen in the figure, the Italian railway network comprises about 70,000 kilometers of operational lines, including 7,700 kilometers of double-track lines, of which 7,600 are electrified, and about 9,000 kilometers of single-track lines, with only half of them being electrified. The Italian railways lines are hierarchically classified as follows. Fundamental lines, about 38%, 6,400 kilometers. These lines are characterized by high traffic density and excellent infrastructure quality and includes international routes and key connection between major Italian cities. Complementary lines, 9,400 kilometers, 56% about. These lines have lower traffic densities and serve as vital connectors with regional basins, providing dense local connections. Node lines, 950 kilometers, 5.6%, developed in key interchange and connection zones. An analysis on the Italian railway networks reveals that not all the regions are served by fundamental lines. Valle d'Aosta, Sicily and Sardinia, for example, only have complementary lines. The node lines, which mainly connect the main regional capitals, consist exclusively of either double or single track electrified lines. Looking at the Italian railway network, it becomes evident that, as a first approximation, all the non-electrified routes falls under the category of complementary lines. A significant differentiation, in fact, exists between electrified and non-electrified lines within the Italian railway network. In total, approximately 12,000 kilometers, equivalent to about 72.4% of the network, are electrified, while the remaining section rely on diesel traction. Interestingly, none of the regions on the peninsula has achieved complete electrification. A more detailed breakdown presented in the table reveals the distribution of non-electrified lines among the different regions. Valle d'Aosta and Sardinia stand out as the only two Italian regions that rely exclusively on diesel traction due to the lack of electrified lines. Finally, we arrive to the vehicles. Trains are the primary service for which the entire railway system is built and serve as the connection points between lines and stations. Trenitalia, one of the most relevant operators in the rail services, classify its vehicles into three different macro categories based on the type of service they provide. A. Frecce, which connect large and medium-sized cities and operate on both high-speed and conventional lines. B. Intercity and international, which connect major Italian cities with each other and offer a more extensive service compared to the Frecce. They also offer day and night services and connect some northern Italian cities with Germany, Switzerland, and Austria. C. Regional. These rail vehicles connect several cities within the same region or neighboring region. The fast regional trains have been completely renewed in recent years to incorporate more advanced and energy-efficient vehicles. The Blues train, for example, manufactured by Hitachi, is the first hybrid train capable of deriving traction energy from either a pantograph, diesel engines, or batteries to cover the last mile. This groundbreaking solution results in fuel savings up to 50% and significant reduction in CO2 emissions. The table is reporting the possible combination of the various relevant characteristics from the analysis of the whole rolling stocks of the Italian railway system that determine the backbone for vehicle taxonomy. Vehicle energy consumption has several hotspots. Traction energy depends on factors such as line characteristic, traction and resistance curves, train mass, speed limits, number of stops, and energy used for onboard systems. Energy supply is required for preheating, air conditioning, electric heating, maintenance, cleaning, and water supplying for trains. Parking service demand involves providing energy to onboard system during extended stop, over 1.5 hours, using the parking mode. In the next lecture, we will use this taxonomy to identify some archetypes to be modeled to properly predict the energy consumption of the whole Italian railway infrastructure.